I was recently chatting with a friend who's a self-proclaimed tech minimalist. He was proudly showing off his new ethically sourced smartphone, designed by a boutique startup in California and assembled in a small facility in Vietnam. He talked about decoupling from the global giants and how this device was a symbol of a new, independent tech era. He looked at the phone with almost a sense of moral victory, convinced he had finally stepped out of the shadow of the world's largest manufacturing shadow. But then, out of curiosity, we started looking up the teardown reports for his specific model. Within minutes, the excitement on his face began to flicker, then fade. The screen, a high-end OLED panel from a Chinese supplier, the battery, manufactured by a giant headquartered in Fujian. Even the internal copper wiring and the tiny magnets used for the haptic engine were traced back to refineries in inner China that process 90% of the world's rare earth elements. It turned out that while the brand name was Western and the final click of the assembly happened in Vietnam, the heart, lungs, and nervous system of his independent device were still pulse-synced with a single country's industrial grid. He sat there, staring at the screen, realized that made elsewhere was often just a different label for the same fundamental reality. It wasn't that he'd been lied to. It was that he, like most of us, had fundamentally misunderstood what technology actually is. We think tech is the sleek app on the screen or the genius code written in a Silicon Valley basement, but that's just the paint on the car. The engine, the chassis, and the fuel are all controlled by the people who learn how to do the one thing the rest of the world thought was low value, actually making things. While we were busy designing the future, one country was busy building it. And now we're realizing that having the best idea in the world doesn't matter much if you don't own the factory that brings it to life.
That is such a perfect encapsulation of the issue. It's a really harsh realization, isn't it?
It really is. And the look on his face, it wasn't anger, it was just confusion. Like the mental model he had of the world just sort of broke.
And that story, it captures the exact dissonance we're seeing across the entire tech landscape. I mean, for the better part of 2 decades, we've told ourselves this story, that the real value in technology is all in the brand. The IP, the user interface.
The immaterial stuff, the code.
Exactly. The stuff you can't touch. We treated the physical manifestation of those ideas, the actual manufacturing, as this commoditized service, something you could just plug into or unplug whenever you wanted.
Right. The factory was just a dumb terminal. That was the whole idea. You send the genius code, you send the CAD file from California, and the product just appears on the other side of the world.
But what your friend discovered, and what we're all starting to realize, is that the factory isn't a dumb terminal anymore.
No, it's the operating system.
Precisely. And that's really what we need to dissect today. We have to strip away the paint, the logos, the marketing, the ethically sourced narratives to look at the machine underneath.
We're talking about what you call the base layer of the global economy. And it's important to say this isn't about, trade deficits or tariffs in the way we usually talk about them.
No, this is much more fundamental. It's about the physical architecture of how stuff gets made, the plumbing of the world.
And to make this manageable, because it's a huge topic, we thought we'd structure this deep dive around, an anatomy of sorts.
Yeah, that's a good way to put it. We're looking at 3 distinct physiological systems, if you will. First, we have the body.
The hardware, the logistics, the actual factories.
Right, the physical form. Second, we have the fuel. This is the entire rare earth supply chain that powers everything from your electric car to the laptop you're probably listening on.
And third?
The brain. This is the industrial AI and the automation grid that is starting to optimize the first 2 layers at a scale that is, frankly, hard to get your head around.
Okay, so let's start with the body. When we talk about manufacturing dominance, I think most people, myself included, usually just think about scale. These giant factories stretching to the horizon.
Right, the sheer size of it.
But I was reading this fascinating account of a factory manager in Dongguan, a guy named Mr. Lin, and his story suggests it's not just about size, it's about velocity.
Mr. Lin is the perfect case study for this.
Yeah.
His reality is what we need to understand.
So get this scenario. A major smartphone brand in California decides, at the 11th hour that they need to change the camera housing on a new prototype. A tiny, tiny change.
Okay.
In a traditional supply chain or even a fragmented global one, that change is a complete logistical nightmare.
Oh, for sure. You're talking about weeks of emails, new contracts, retooling expensive molds, shipping samples back and forth across the Pacific.
The whole process grinds to a halt. But for Mr. Lin in Dongguan, this isn't a crisis. He says it's just a Tuesday.
Because of where he is. It's all about the location.
Right. Exactly. He's operating inside what the locals call the 1-hour industrial circle. He needs new custom screws. The supplier is literally next door. He needs a specific formulation of tempered glass. That facility is down the block.
He doesn't even need to make a phone call, probably. He just walks over.
That's what he said. He needs a custom circuit board printed for the new camera that's 2 streets over. He described it not as a supply chain, but as a circulatory system. The blood is always pumping.
That's a powerful metaphor.
He said he can walk out of his factory, gather all the new components for a completely revised prototype, and have it assembled and testing before an engineer in Silicon Valley has even gotten a reply to their first email.
And that concept, the 1-hour industrial circle, that is the key thing people miss when they talk about diversifying supply chains. It's the part that's so hard to replicate. Well, people look at a map and think, okay, we can build a new factory in India or Mexico or Ohio. And you can build the building, you can put machines in it, but you cannot overnight replicate the ecosystem that Mr. Lin is swimming in. It's the density. The density is what creates that incredible efficiency.
But doesn't that density exist elsewhere? I mean, Germany has incredible industrial zones, right? The US has the Rust Belt, which people are trying to revitalize. Why is the Pearl River Delta, or what they now call the Greater Bay Area, so fundamentally different?
It's a difference of scope and integration. It really comes down to the friction of distance and the integration of what some analysts are calling the Shenzhen cohort, which is all over CES 2026.
The Shenzhen cohort, I saw that term.
In Germany or the US, you might have a fantastic cluster of, say, automotive suppliers, or a great cluster of medical device manufacturers. But in the Greater Bay Area, which strategically integrates Shenzhen, Dongguan, Guangzhou, and Hong Kong, you have a cluster of everything.
It's not specialized.
Exactly. And that allows for this incredible cross-pollination. A drone manufacturer can borrow a battery technology that was developed for an electric vehicle and use a sensor that was perfected for a smartphone and source the carbon fiber for the chassis from a company that usually makes sporting goods, all within a 50-mile radius.
That's incredible. And that's what leads to what we saw at CES this year, because the whole narrative used to be designed in California, assembled in China. But looking at the drones and the robotics coming out of this Shenzhen cohort, that script has totally flipped.
Completely flipped.
Yeah.
The old model was contract manufacturing. You pay them to build your idea. The new model, which they are pushing hard, is original innovation that's born from the factory floor itself.
Because Mr. Lin can iterate so fast?
Precisely. Because he can fail and fix a design 10 times in the amount of time it takes a Western competitor to even try once, the innovation cycle is just radically accelerated. They aren't just building the hardware anymore. They're starting to define the form factor. They are shaping what's possible.
So the proximity to the means of production, it actually drives the evolution of the product itself. It's not a passive service.
And this isn't just a happy accident of capitalism. The government has formalized this with the Greater Bay Area strategy. They aren't just letting these cities sprawl. They're actively assigning them roles in a single integrated mega cluster.
So what are the roles?
Broadly speaking, Shenzhen is positioned as the brain. It's the R&D, the venture capital, the startups. Guangzhou is the muscle, the heavy logistics, the port, the advanced manufacturing. And Hong Kong is, you could say, the vascular system, the global finance, the IP legalities, the bridge to the outside world.
So it operates like a single organism with a GDP larger than most nations.
That's the goal, and it's working.
Okay, but I have to play devil's advocate here. We keep hearing, and it's true, that labor costs in China are skyrocketing. The era of cheap labor is over. So how does Mr. Lin keep his prices competitive if he has to pay his workers more and more? Or is this whole model destined to collapse under its own success?
That's the question. And that's the assumption that many economists in the West made about 10 years ago. They saw the rising wages and said, aha, manufacturing will now move to cheaper markets: Vietnam, Bangladesh, Indonesia.
And it did for some things. T-shirts, shoes.
For low-value textiles, yes, absolutely. But for high-tech, for complex electronics, no. Because China solved the labor cost problem in the most direct way possible. They removed the labor.
The dark factories.
Exactly.
Yeah.
We really need to talk about the scale of automation because it's on another level. We're not just talking about a few robot arms bolting things together on a line.
No.
We are talking about entire facilities run by companies like Xiaomi, BYD, and their countless suppliers that operate 24/7, often without lights on, because there were no human eyes inside to see what's happening.
I looked up the numbers and they are just staggering. As of 2024, there was something like 4.66 million industrial robots active globally, and the vast majority of new installations were in China. It's not even close.
But again, like with the factory locations, don't get hung up on just the raw number. It's the cluster effect applied to the robotics industry itself. In the Yangtze River Delta, for instance, you don't just have the factories using the robots.
You have the companies that make the robots.
And the companies that write the software for the robots, and the companies that design the sensors for the robots, and the companies that cast the high-tensile steel for the robots, all in the same zip code.
It creates that flywheel you talked about.
It absolutely does. If a robot on a production line has a glitch, you don't file a ticket and wait for a technician to fly in from Germany or Japan. The engineer who literally designed that specific servo motor drives over in 20 minutes. They fix it, they update the code, and then they can push that update to the entire fleet of robots across the province by the end of the day.
That's insane agility.
And it has created what we're now calling the end-to-end robotics stack.
Unpack that term for me, end-to-end. What does that mean in this context?
Well, in the West, a manufacturer is typically a systems integrator. They buy a robot arm from a company like Fanuc in Japan, a gripper from another company, the vision software from a third, and then they pay a consultant to bolt it all together and hope it works.
A bit of a Frankenstein's monster.
It can be, but Chinese firms like Lens Technology or Lingyi iTech, who are huge Apple suppliers, are vertically integrating the robot itself. They are building the chassis, they are manufacturing their own precision reduction gears, they're designing the controller, and they're writing the AI vision system in-house.
So they own the means of production, for the means of production.
You've got it. That is the crucial advantage. And it gives them a speed and a cost advantage that cheap labor in another country simply cannot compete with. It's a different paradigm. So if you're that boutique startup in California trying to build an ethical phone, sure, you can find cheap hands in Vietnam to do the final assembly, but you cannot find an automated, AI-optimized, end-to-end robotic ecosystem that can produce millions of units with near-zero defects at that speed.
That only exists in one place.
For now, at that scale, yes.
So we are, in effect, renting the body. My friend's phone, regardless of where the final screws were tightened, was fundamentally born from that body. But a body needs fuel. It needs energy. It needs blood. And that brings us to the second layer we need to talk about. The fuel.
Right.
And I'm not just talking about the lithium in the battery, although that's certainly part of it. I'm talking about the elements that are even more critical and even more concentrated, the rare earth elements.
This is probably the most misunderstood part of the entire global supply chain.
I think so, because people have this mental image of mining as this, brute force industry. You just dig a big hole, you find the right rock, you crush it up, you sell the rock.
Digging dirt.
Exactly. But I was reading this profile of a chemical engineer named Xiao Mei, who works in Botu in Inner Mongolia, and her day-to-day reality just completely contradicts that digging dirt narrative.
Botu is ground zero for this entire industry.
So Xiao Mei, she works with two elements in particular, neodymium and dysprosium. For anyone who doesn't know, these are the magic ingredients for the high-performance permanent magnets that go into literally every EV motor, every wind turbine, every smartphone speaker.
They're essential for the green transition.
Absolutely. But she's not a miner. She's a chemist. She described her work as moving from the brute force era of mining to a surgical era of purification. She talks about purity levels of 99.999%. To her, she isn't just processing ore, she genuinely views herself as one of the architects of the global green energy transition.
He's not wrong.
She knows that without her lab's specific output, the net zero climate goals being made in Paris or London or Washington are just fantasies on paper.
Xiao Mei is 100% right. And understanding why she is right requires us to get a little technical just for a moment about the periodic table. We call them rare earths, which is a bit of a misnomer. It implies they're scarce. Geologically, they aren't that rare.
Right, I've heard that. The U.S. has plenty of rare earth deposits. Australia, Vietnam, Brazil, they all have them.
Exactly. If it were just about digging up rocks, there would be no monopoly. This is the key point. The bottleneck isn't the mine. It's the separation. It's the chemistry.
Okay, explain that.
Rare earth elements are all part of a group called the lanthanides. If you look at them on an atomic level, their outer electron shells are incredibly similar. It means they are, chemically speaking, almost identical.
So they all stick together in the ore.
They're essentially glued together. Trying to separate neodymium from praseodymium, which are often found together, is like trying to unmix a cup of coffee that already has milk and sugar stirred into it. You can't just sift it out.
So how do you do it?
You have to use incredibly complex solvent extraction processes. We're talking about a chain of thousands of mixer-settler stages, huge tanks where you mix the crushed ore with powerful acids and organic solvents. You let it settle, you separate the layers, and then you do it again and again, thousands of times. Each stage pulls out a tiny fraction more of the element you want.
And I'm guessing that's not exactly an environmentally friendly process.
It is incredibly toxic and difficult, if not managed, with extreme precision. And this is the key to the whole story. For about 30 years, from the 80s onward, the West decided we didn't want to deal with that mess. We shut down our processing plants, like the one at Mountain Pass in California, because of the high environmental costs and regulations.
We offshored the dirty work.
We offshored the dirty work. And while we were doing that, China and engineers like Xi Mai spent those 30 years mastering the chemistry. They weren't just doing it, they were perfecting it. They optimized the flow rates. They developed new solvent mixtures. They engineered better waste management systems.
So while we were offshoring the pollution, they were monopolizing the intellectual property.
That is the crucial distinction that everyone needs to understand. It is a technological monopoly, not a geological one. The data is clear. China controls roughly 90% of the global separation and refining capacity for rare earths.
90%.
90. And they have weaponized that capacity with a very clever long-term strategy that's often called two-tiered pricing.
How does that work in practice?
It's a mechanism that's often managed through their giant state-owned enterprises, their SOEs. Essentially, if you are a domestic manufacturer, a company building EV motors inside China, you can purchase these processed rare earth oxides and magnets at a lower price point than a foreign company can.
So there's a home team discount, a big one.
A very significant one. So if you're an EV manufacturer in Detroit or Stuttgart, you're paying a premium for your magnets, plus shipping, plus any tariffs. The message is clear. If you move your factory to Baotou or Dongguan, you get the critical materials at the source price.
It's a gravitational pull for industry. The strategy isn't just to sell the minerals to the world, it's to force the world's most advanced manufacturing to relocate to where the minerals are processed.
Exactly. And recently, it seems they've started building walls to keep that gravity contained. I'm thinking of the export restrictions that came into play.
The patent wall, as it's being called, this was a huge development. As of late 2023, China placed restrictions not just on the materials, but on the export of the technology for rare earth extraction and separation.
Wait, hold on. So they aren't just saying, we might not sell you the finished magnets. They're now saying, we will not teach you how to make them yourselves.
Correct. So even if the U.S. fully reopens that mine in California tomorrow and is willing to deal with all the environmental regulation and cost, they face a massive skills and technology gap. The most efficient, lowest cost, modern processing techniques are now considered Chinese intellectual property, and that IP is officially no longer for sale.
That makes the idea of catching up incredibly difficult. You're not just building a factory. You have to reinvent 3 decades of advanced chemical engineering from scratch.
And while the West is trying to reinvent the wheel, China is consolidating its power. Look at the formation of the China Rare Earth Group. This was a state-orchestrated mega-merger of several of their biggest state-owned mining and processing entities into one giant.
A super entity. A super entity. In antitrust economics, we use something called the Herfindahl-Hirschman Index, the HHI, to measure how concentrated a market is. An HHI score above 2,500 is considered a highly concentrated monopoly. The Chinese rare earth sector, after this merger, is now scoring over 7,200.
Wow. So that is effectively a single entity controlling the global tap for the building blocks of modern technology.
And that tap, as you said before, controls what we can call the green energy paradox. The entire world wants to save the planet with wind turbines and EVs and high-efficiency motors. But the hard physical reality is that the road to that green future runs directly through Xiaomei's lab in Baotou. It's a single point of failure for the entire global sustainability project.
So we have the body, the hardware clusters, we have the fuel, the rare earth processing. But a body and its fuel are useless without direction, without a nervous system. And this brings us to that third and maybe most complex layer, the brain.
This is where the story shifts from physical atoms to digital bits. But it's really important to note, unlike the Western tech narrative, which is often obsessed with consumer apps and social media, this is about industrial AI.
And I want to look at this through the eyes of another person, old Zhang. He's a foreman in a factory in Hangzhou. I read about his personal transition, and it's fascinating because it really mirrors the broader shift in the entire country.
Right.
For 20 years, old Zhang's primary value on the factory floor was his ears. He could walk down a long line of injection molding machines and just listen. He knew that a specific clank from machine number 7 meant a bearing was going to fail in about a week. He was the human sensor.
The intuitive craftsman. Every old factory has a guy like that.
Exactly. But today, old Zhang doesn't walk the line anymore. He sits in a climate-controlled room facing a massive wall of screens, a digital twin of the entire factory. He's looking at real-time heat maps, vibration analysis, and predictive maintenance logs from thousands of sensors.
So the system is doing the listening now.
And it's not just reporting what already happened, it's predicting what will happen. It tells him that a machine will fail in 3 days because of a microfracture that no human ear could possibly hear.
And that transition from the intuition of the individual worker to the prediction of the algorithm, that is the core of what's being built, China's digital nervous system.
To old Zhang, he said the factory feels alive now. It talks to him. But what really struck me was that this isn't just one advanced factory buying some fancy software from SAP or Siemens. This seems to be happening everywhere, all at once.
And that is the power of data aggregation in a state-led economy. In the West, industrial data is extremely siloed. Ford has Ford's data. General Electric has GE's data. Tesla has Tesla's data. And they guard it jealously from each other.
Of course, it's a competitive advantage.
Right. But in China, because of the cluster effect we already talked about, and the ubiquity of state-influenced digital platforms, the sheer volume of industrial data they are aggregating is unprecedented.
It's the flywheel again, but with data.
It is. More robots mean more sensors. More sensors generate more data. More data trains better, more accurate AI models, and better AI models make the robots more efficient and predictive, which justifies deploying even more robots. It's a self-reinforcing loop.
But what about the regulatory side of this? I mean, in Europe, you have GDPR, which is very strict. In the US, we have a growing patchwork of privacy and data usage laws. How is China handling the governance of all this AI? It seems like a Wild West.
Well, the Leiden Asia Center had a report on this, and they described the official approach as prudent but accommodative.
Prudent but accommodative. That sounds like a very polite way of saying move fast and break things, which was Silicon Valley's old motto.
It's a bit more nuanced than that, I think.
Yeah.
It means they don't try to strangle the baby in the crib. They allow a new technology to scale, whether that's facial recognition, autonomous logistics, or these data-hungry dark factories, to reach a point of maturity and national scale before they come in and impose the strict guardrails.
So they prioritize developing the capability first,
over the immediate regulation of the potential risk. It's a different risk calculus than you see in the West, where the fear of misuse often leads to a regulatory straitjacket from day one.
So old Zhang gets his digital twin dashboard because the regulators didn't step in 5 years ago and say, wait a minute, you can't connect all these machines to a provincial cloud network yet.
Exactly. And now that this system is built and proven, they are exporting it. And this is where we have to talk about standards. It's the boring stuff that actually rules the world.
The ISO standards, the ITU protocols, all that.
Yes. China is now aggressively working to set the international standards for industrial AI and smart cities through bodies like the UN and the International Telecommunication Union, or ITU. They're no longer content to just follow Western standards. They want to write them. And they're doing this via the digital Silk Road.
Which is the big infrastructure push into the global south, right?
It is. So if you're a developing nation in Africa or Southeast Asia or the Middle East, and you buy a Chinese-built smart port or a 5G grid, you're not just buying the hardware. You are installing the Chinese operating system. You're adopting their technical standards for how data is handled, how AI communicates, how the network is secured.
You are locking yourself into their technological ecosystem.
And once your entire port or your capital city is running on that standard, the switching costs become astronomical. It is a form of deep structural soft power that can last for decades.
And we shouldn't forget their capability in the pure AI space either. We mentioned DeepSeek before we started.
Right, DeepSeek. This is a really important example. For a long time, the Western assumption was that without access to the absolute cutting-edge chips, the NVIDIA H100s and so on, China wouldn't be able to compete in training these massive large language models.
The export controls would keep them behind.
That was the theory. DeepSeek proved that theory wrong. Their latest models are benchmarking competitively with the best from OpenAI and Google, which is a shock to a lot of people.
So how are they doing it? If they are restricted from buying the best chips, how are they building the brain?
It seems to be through incredible architectural efficiency. They have optimized their software and their training methods to run on less powerful hardware or to chain together fleets of domestic chips more effectively. It's a powerful reminder that necessity is the mother of invention. By cutting off access to the brute force hardware, the West may have inadvertently forced them to become much, much smarter about software architecture.
Okay, so let's try to assemble this full picture here. We have the body, the ultra-efficient logistics, and end-to-end robotics that physically built my friend's phone. We have the fuel, the chemical mastery of rare earth that allows the phone to vibrate and its battery to charge. And now we have the brain, the industrial AI, and emerging global standards that are optimizing that entire process.
And old Zhang, Xiaomei, and Mr. Lin are the human faces of that trifecta. Each of them represents a layer of this dominance.
It really brings us right back to that moment with my friend, sitting there staring at his independent device. He thought he could just buy his way out of the system.
But the teardown report showed him the hard truth. You can outsource the final assembly, but you cannot outsource the industrial base. The paint on his phone, the brand, the minimalist ethos, the marketing copy written in California, that was all Western. But the chassis, the engine, and the fuel were all, as you said, pulse-synced with this single integrated grid.
It makes the phrase "made elsewhere" feel incredibly shallow. It hides the depth and the complexity of what's actually happening underneath.
It hides the fact that this wasn't some accident. This supply chain wasn't just the free market finding the cheapest price. It was built deliberately over decades, through 5-year plans, through state initiatives like the H63 program for high-tech development, through a relentless state-level focus on mastering this base layer.
And while we in the West were busy, celebrating app valuations and software unicorns,
they were cementing control over the physical reality of how the modern world is actually built.
And now, looking at that Shenzhen cohort at CES, it seems they're done waiting in the wings. They aren't just the factory anymore. They are becoming the architect. They're setting the trends, not just assembling them.
So the key takeaway here isn't just about geopolitics or trade wars. It's much deeper. It's about the very definition of what technology is in the 21st century.
Right.
It is. We need to stop thinking of technology as just the idea or the code. In today's world, ideas are cheap. Code is abundant. Real, impactful technology is the capacity to execute that idea at massive scale, with control over the necessary raw materials and with the intelligence to optimize the whole system. And the balance of power in that execution, in that base layer, has fundamentally shifted.
It's a shift that's totally invisible until you decide to peel back the casing of the device in your hand.
And once you see it, you can't unsee it. You start to realize that the digital world we all live in is entirely dependent on a physical world that, for the most part, we have largely stopped paying attention to.
It makes you grapple with a very fundamental reality. If the digital world runs on physical hardware, and that hardware runs on a single country's industrial grid, it may not matter in the long run who writes the software if they don't also control the switch.
That is the new reality of the invisible assembly line.